Let's get started. Good afternoon and welcome to our Optimus SBR webinar entitled Hacking the Brain to Create Better Data Visualizations. If you're someone who works with data to produce analytics and reports, or if you're a consumer of such information and have felt there are opportunities to improve how data and information are communicated, I think you're really going to enjoy the next half an hour. My name is Doug Wilson and I lead Optimus SBR's technology consulting and data practices. Joining me today to present our webinar will be Eric Tobias. Eric is a principal within our data team and brings 30 years of experience working across multiple data disciplines within many industry sectors. Eric is actively working with many of you joining the webinar today, and I'm sure you share my respect for the value he delivers to our clients. We'll be recording today's webinar, and at the conclusion, we'll provide registrants with a link to the material. If you have questions during the webinar, please use the Q&A function available on the screen. Eric's going to remain available at the conclusion of the webinar to answer any questions you may have. Before I turn things over to Eric, I wanted to ensure people have a little bit of background on Optimus SBR. We're one of the largest independently owned consulting firms in North America. We were founded in 2010 as a result of 3 different firms coming together. Over the years, we've completed 8 acquisitions and have grown rapidly to now have over 250 staff members. We're really proud of our people, our entrepreneurial and bold culture, and our relationships with clients and the community that have resulted in over 30 awards and a pretty incredible growth story. We have 8 primary service offerings with several discrete capabilities across those service offerings. Today, we're focusing on one of those capabilities within our data and analytics practice. Data and analytics is a growth area for Optimus SBR with a lot of recent work ranging from data strategy and governance through to data architecture, data infrastructure, and even the development of statistical models. Today, we look forward to sharing some insights around best practices in data visualization. That's really all I wanted to cover with respect to the firm. I look forward to seeing you on subsequent webinars as we plan on making these regular events. And I'm really pleased to turn things over to Eric, who will now dive into the content of the webinar. Eric?
All right. Greetings, everybody. We're going to be going through hacking the brain to create better data visualizations. So this is all about the science of visual best practices. Believe it or not, there is a science to it. This is not something that's just based off of preferences that some product manager at a visualization company came up with. It really is scientifically based. It's based off of things like PET scans and MRI scans, et cetera, et cetera. So the first thing that we have to understand is there's a difference between 2 major functions, visual functions, that's perception and cognition. And that's going to be very important for the rest of this presentation. So I'm going to go into that and explain that a bit. So perception is all about how we take in visual stimuli in this case. So it's all about this seeing that we do moment to moment. Compare that to cognition. Cognition is the process where we evaluate, consider, and understand what it is we're looking at. So perception happens very, very quickly, whether we know it or not. Cognition definitely takes a bit longer. So by virtue of the fact that we know the difference between perception and cognition, what we're going to go over today are some basic visual best practices that will help you take advantage of perception and avoid cognition wherever possible. So let's start by taking a look. Which is better, A or B? So there's some very distinct differences between these. The one on the left there, A, breaks a whole bunch of visualization best practice rules. I won't go over the entire list, or we'll be here much longer than we have time for. Compare that to B. B implements a lot of the visual best practices. It reduces use of color. It highlights certain KPIs. It reduces the density of some of the information. So that takes much better advantage of some of these visual best practices. So one thing to be really aware of, and we're not going to actually go have an entire anatomy of the brain session, I promise, but there's really kind of 2 things that we want to highlight here. The shorter the time between seeing something visually with your eyes, so perceiving it, and comprehending it, which is cognition, the more productive your users will be. So if you're able to take visual perception into account, then you will create dashboards that people will find intuitive. So if somebody looks at a visual and they immediately understand that, that dashboard is going to be considered intuitive, which means that you're taking advantage of these visual best practices and these visual features that we're going to go over. Interesting to note, the brain can process a lot of information, but in a very, very small amount of time. So what you have to understand is when we say a very short amount of time, we actually mean 40 milliseconds. So that is very, very small. I've actually looked to see what 40 milliseconds amounts to, and it's, for example, one flutter of a hummingbird's wings, for example. So we're talking about very, very small amount of time that you have before the brain decides, okay, this is too complex. So if the brain is able to perceive it and it uses simple basic rules, it'll be processed by the occipital lobe, which you can see highlighted up there on the top left. If it's a little more complicated and the brain determines that it needs to process it cognitively, it gets forwarded to the frontal lobe, which is there on the front. Totally different area of the brain, and it requires a lot more processing in that area of the brain. So what we have to do is we have to try to take care of that automated system that's on the backside there, the occipital lobe. And to do that, we're going to have to apply some of these visual best practices. So if you'd like an example, I can give you one. People may have seen this before. I enjoy this one a lot. We're going to put up a series of numbers, and all we want is we want to know in this series of numbers, how many fives are there? So you're probably finding that that's a lot of work. As you look through there, there's two ways that you can approach this. One way to approach this is to use math and numeric matching. So you look through the numbers 0, 3, 9, 4, 8, 6, 9. Finally, you get over here to a 5. So you count 1 and you keep going until you reach, oh, there's another 5. So that's 2. Or you do pattern matching, which is you try to find shapes that are in the shape of what we know as a 5. Either way, both of those, because of the number of evaluations the brain has to make, your brain will have decided to process that cognitively. So it's going to take a lot longer. That has to be done what we call attentively. And what we're going for is going for pre-attentive processing of visual information. So let's try this again. And I'm going to make one change and I'm going to implement one visual best practice. And we're going to see if it becomes easier for you to spot how many 5s there are. You should have been able to see that there are 6 5s in this list. And all we really did here is we used a pre-attentive feature called perceptual pop-out. And really what that is that uses color intensity to highlight, or in a lot of situations, we would call it bold. So bold those numbers. And we're able to then see them, they jump out right out at us and we don't have to worry about it. And we're actually now processing this pre-attentively. Here's another example. So I'm going to give you some numbers. And if I were to ask you 2 questions, we would want to know the answer to these. So the first question is, this is going to be some sales information over a 4-year period. Have the sales increased or decreased in total? And of the 3 categories I'm going to show, which one is growing the fastest? So now we've actually made this even worse, because what we've done now is not only do you have to process this cognitively, you have to do math on top of that, which requires even more advanced cognition. So in this particular case, one of the things that is always good to know is that anything that is either using words or numbers automatically has to be processed cognitively. So that thing that we use a lot, our crosstabs or our tables, that's actually the slowest possible way for the brain to comprehend the information it's looking at. If we can convert this numeric data into something that is pre-attentive, then we can actually get the information across to our users much more quickly. So this example, crosstabs in general cannot be processed pre-attentively. So those are going to have to be shipped off to the frontal lobe and go through a lot more processing. So let's try something a little different. Same question. I'm going to present the information slightly differently, or very differently, and we're going to see if we can answer these questions more quickly. So we should be able to see almost without even realizing that we've understood it, we will see that the lines are going up, which means the sales are increasing. And then we see that the red line is growing more than any of the others. So that's the information that we're able to understand very, very quickly without having to go and process that cognitively. So here we used position and we used color, hue, to imply meaning, and the brain was able to interpret it very quickly. That can be done pre-attentively. So what's the number one error that people make? And unfortunately, I have the pleasure or displeasure of being able to look at a lot of different visuals out there. And so I will see that there are some good examples of some very bad visuals, and we try to avoid. But one of the ones that almost everybody seems to make a mistake with, at least getting started, way too much color. So hopefully that's hurting everybody. We like to, make sure that that jumps out at you. Color can only be processed pre-attentively a couple of ways. So we're going to get into that here in just a second. So the first thing to think when you're talking about trying to present information, don't try to make the primary way that you impart information be done through color. You'll see here in a moment, it's not the most effective one. So what is pre-attentive? Well, there are 4 classifications of pre-attentive visual features. There's form, color, position, and motion. And I will give you examples of all of these in just a second. Form is shapes, patterns, and proximity. Color has to do with how the human eye takes in these different light waves through rods and cones in the eye. Position has to do with the placement of objects or things next to each other. And motion has to do with the movement of objects near each other. And when all is said and done, here are the lists. These are the pre-attentive features that you can make use of. It's important to note that there are some specialists out there who think that there are a couple more. There's some that think that there are fewer of these, but in general, these are all the ones that are most frequently recognized. So what I'm going to do is I'm actually going to show you some examples of it, and we'll go through these fairly quickly. When we talk about line orientation, what you're going to notice before anything else is that we have a bunch of shapes, and one of them is oriented slightly differently. So up there on the top left. Similarly here, there's one kind of near the bottom right that has a length or width that's longer than all the others, so it pops out at us. Here's one that's size. Again, it pops out. Enclosure, we notice those 6 things before we noticed anything else. Shape, we have a bunch of shapes and one that's slightly different than the rest of them. We notice that first. Curvature, if we have a lot of straight things and something that's curved, our brain processes that quickly. Convexity or concavity. So in this case, what we notice first is that some of these are indented and some of these are outdented. So the brain also processes convexity and concavity pretty quickly. In terms of color, we have hue. You'll notice here that the first thing you noticed was the red as opposed to all the blue. When we look at those, hue means difference in color. So a red and a green, or a blue and an orange, etc. Color intensity is the same color, just either darker or lighter. So this would be more equivalent to a gradient scale, for example, whereas the color hue is more of a categorical scale that's going to have individual discrete colors assigned to it. When it comes to position, there are 2 things. There's the 2-dimensional position. So what we notice here is that one of these is not lined up like the rest of them. Its 2-dimensional position is slightly different. We notice that first. And stereoscopic depth. Do not confuse this with 3-dimensional. If we talk about things in Excel, for example, if you have bars, a bar chart, a 3-dimensional bar chart will automatically be too complex and will be processed cognitively. What we're saying here, stereoscopic depth just means in front of. So in this image, we can see that there is part of this that is behind part of the other. So we can tell that there's depth, but we cannot process it three-dimensionally. If we try to do it three-dimensionally, it automatically gets shipped to the frontal lobe, and again, takes longer. We have to process it cognitively. In terms of motion, you'll notice here we have some flickering going on. Our brain notices flicker, so that's an important one, or change in state. Direction of motion. In this case, we notice that one of those lines is moving differently than the others. And velocity. In this particular one, we notice that there is a bar up there that's moving faster than the rest of them. Again, those three are pre-attentive. So if you'd like to see some proof, we're going to go through a fun little exercise. I enjoy this, and I've worked with a lot of different people in visual best practices. And it often is something that people find very fun. So what we're going to do is we're going to show you a number of circles, and we're going to show you 6 different images. And all we really want to know is there a red circle amongst all of the blue ones or not? So there's either a red circle present or the red circle is absent. And what we're actually going to show you is a sequence of images, and then we'll say whether it's present or absent. And just because I'm presenting this and I'm a very, very generous person, instead of 40 milliseconds, I'm actually going to put it up for 200 milliseconds. So it's 5 times more than you actually need. So in reality, if you were to do this on your own, the brain would be able to process what we're going to be looking at within a fifth of the time that you're going to be seeing it. All right, so let's go. So present, present, absent, absent, present. So as you can see inside there, you were able to process that even though that image was only flashed up for a very short period of time. And that's true of really good visuals. If you have a dashboard and you've done a lot of the visual best practices and you have implemented those properly, you can actually display that to a person, flash it in their face, take it away immediately, and there will still be information that they will have retained from looking at it. Because you use pre-attentive features, you're actually able to understand some of the information that came through even before you realize that it's happened. How'd everybody do? Hopefully you did well. So that was using color. That was color hue to be exact. Now we're going to use a boundary between the colors. So in this case, in this image, the boundary between the red and the blue is vertical. So inside here, we would say vertical. I'm going to flash more images up, and those images may be vertical or horizontal. So again, let's see how everybody does. Vertical, vertical, horizontal, vertical, horizontal, horizontal. So again, 200 milliseconds with each one of those. Inevitably, people do really well at this. So hopefully everybody gets your gold trophy here. And we're going to mix it up. So before we used color to differentiate, now we're going to use shape to differentiate. So here we have lots of different colors, blue and red, but we have either a vertical line, a vertical boundary between circles and squares, or again, we'll have a horizontal boundary. Vertical, vertical, horizontal, horizontal, vertical, horizontal. So again, just to prove that point, we flashed that up for just a moment and you're able to comprehend exactly what was presented there. So that is putting into effect visual best practices. Something to be very careful about though, watch out for too many or incompatible pre-attentive features. Those will force people to have to process it cognitively, even though you think it shouldn't. In this case, we're actually mixing color, hue, and shape at the same time in a way that is not pre-attentive. So how many red squares are there? Well, there's actually 3, but because of the way we used color and shape, it ends up requiring us to process this cognitively because we use it incorrectly. Or, and this one, is there a red circle? Well, yes, there is a red circle, but because of the way we mixed our color and we mixed our shape, it ended up being not pre-attentive. So just to introduce you all to some of how my brain works, one of my pet peeves, obviously we know that Facebook is one of the founts of all human truths, but one of the things that I have seen come up on Facebook numerous times, and I can't tell you how often it really irks me when it comes up, is somebody will post on something on Facebook that says 99% of people can't find the C in the following image within 2 minutes. So I will let you take a look at it, and I'm not going to give you 2 minutes to do that because we don't have the time. Did you need 2 minutes? Probably not. So congratulations, you are one of only 1% of people on the planet Earth that can do this. No. So instead, what we look at back here is we should be able to see the C amongst all the O's. And that will probably happen if we flash that up in front of your face within 40 milliseconds. Odds are you would be able to tell instantly whether there was a C or there wasn't a C present inside there. So not only is 2 minutes excessively long, it should be 99.9% of people that can see those should be able to perceptively process whether that's there or not. So what we have to do is we have to take those visual features. So remember, we had line orientation, line length, line width, line size, etc. Those are the visual features. And to use them properly, we have to combine those with data. So we have to know the type of data we're trying to represent. And there really aren't as many as you're thinking. For the technical people that may be out there, we're not talking about data types like strings and Booleans and integers. We're talking about very, very basic types of analytical information that we present. There's categorical data. That's where we take data that belongs together based on some sort of characteristic. So in the list, North America, Europe, and Asia, you can figure out what the common characteristic of all of those is without me even having to tell you. Those are continents. Eric, Sherry, and John, you can probably tell immediately that those are names or even first names. Pizza, Twinkies, and potato chips. Odds are we're probably getting into junk food over there or some sort of food. So categorical data belongs together on characteristics. Sequential data, that's ordinal data that has a sequence to it that's implied. So if we talk about our medals, so everybody got a gold medal, I'm assuming on our prior exercise. So we talk about gold, silver, and bronze. When the Olympics happened just recently, they didn't announce the silver winner and then the bronze winner and then the gold winner. That wouldn't make sense to anybody because it's been ingrained in our brain that the sequence of those three colors or medals is gold, silver, and bronze. Similarly, for degrees, there's doctoral, master's, and bachelor's. There's a sequence to those that we understand. Or one of the most famous of all ordinal data, dates or times, May, June, July, 8 a.m., 9 a.m., 10 a.m. There's a sequence to those. If you try to place that data in another, and then there's quantitative data, how much of something. So 10 million or 10,000, 1 million, 4 billion, that helps us understand very quickly the scale of those numbers. One is much bigger than the other, and the 4 billion is way bigger than all the others, etc. So quantitative data is how much of something. All right, so if we take our visual features and we combine that with our data types, we end up with the optimal visual best practices, where the effectiveness decreases as we go down the list. So if we're dealing with categorical data, so again, that could be Department A, Department B, Department C. The first thing we should use is position. Second thing is to use different colors, so categorical color palette, for example. If it's ordinal data, data that belongs in a sequence, then we use position first and size second. So notice that the change inside here, if it's ordinal data, color used is fourth in the list, not second in the list. And with quantitative, it's position first, length, then size, color intensity, etc. Notice the primary way to present visual information the most effectively and the fastest is to use position. Color is much further down the list. So people tend to overuse color when they really shouldn't. Some things to remember when you're taking these visual best practices: make sure your data is condensed, organized, targeted, and concise. We really want to make sure that we are targeting the people who need it in the way that they need it, in the way that they understand it. But we don't want to overwhelm them. Give them enough information to answer their question, but don't overwhelm them with so much detail that they get lost. For example, is this a good dashboard? I would hazard to say no. If I received this as an executive, I would look at it and I would probably not even bother trying. Or is this a better dashboard? I would argue this is a much better way of presenting that. Something to be aware of, another gotcha with color, is color deficiency. This is what a normal red-green looks like to most of us. The traffic light color palette, which everybody really wants to use. Red is bad and green is good. There are subsection, about 11% of people, actually 11% of males, will have one of the following 3 color deficiencies. Protanopes have a red-green. You'll notice the red that most people see and the green that most people see is very, very different for a protanope. Deuteranope, again, very, very different than what normal red-green is. Tritanope, that's really, really different. So the thing to keep in mind here is red and green is actually one of the most problematic of the color palettes, even though everybody wants to use it. Don't use the traffic light color palette. Or another one we'll pick on, the pie chart. Everybody likes a pie chart. There's actually only 2 accurate pie charts. This is one, pie that I have eaten, pie that I have not yet eaten. And this one, services revenue versus software revenue. Why is this okay? There's only 2 slices to it. Keep that in mind. If it has more slices, like this one, we end up having a real issue trying to compare some of these. What we're trying to achieve here is maximally precise approximation, which sounds like an oxymoron, but really isn't. It means we want the person to be able to, as precisely as possible, understand the scale of the values compared to each other and be as close to exact as possible without actually being exact. So if I ask you clementines or coconuts, which do we sell more of? Those 2? It's really hard to tell. So what we normally do with a pie chart is we put labels on it. Remember, labels are numbers. Those have to be processed cognitively. So we've just ensured that while this has color and shape and size, it now has numbers and has to be processed cognitively. There's the same information. It may be boring old bar chart, but now coconuts and clementines right here. I don't even have to know what the axis on this is, and I can see that one is more than the other. So the lesson about all of this, a pie chart can always be represented better if you use a basic bar chart. We're not going for eye candy here. This is not for infographics. This is for day-to-day analytics, and we want to be pre-attentive. If we want to do that, a bar chart is going to work much faster. So a few next steps. Remember the types of data. We talked about those, categorical, ordinal, and quantitative. Keep that cheat sheet, the pre-attentive features, and always have that matrix available, at least until you have it memorized. That will help you make the best choice with the data that you have. And with that, we want to thank everybody for being here. Thank you for attending.